So we're going to go ahead and look at this problem. It's a higher level, level 2 calorimetry problem. Just because it has so many different numbers in there, you have to get in the right spot. You have to do some subtracting, that kind of stuff. The key thing in this is looking for that equilibrium temperature and realizing that it actually stands for two things. So I see this equilibrium temperature right there. And so remember that that is actually the T final of both items. So that's the big key thing, look for that. Also, in your problem, make sure that you've corrected the specific heat of lead. It should have been that other value. All right, so in this problem, we're going to do we're going to say our negative Q is equal to our positive Q. And this is going to be the hot one, and then that's going to be the cold thing. So I'm looking through, here's a temperature, and here's another temperature. And you can tell this is the one that's over boiling, and it's going down to that value. So that's going to be the hot one. You can tell this is lower, and that one's getting warmer. So this side is going to be the lead, and the right side is going to be the liquid, the unknown liquid. And don't leave that negative out. So I need to fill out all of my numbers off to the side, or I can go ahead and substitute it in my MCAT equation. Either one works. So then we have M times C times delta T. And then I'm going to say that if I kind of look for it and I'm trying to figure out what it wants, it says, what is the specific heat capacity of the liquid? So I can go ahead and make my terms list, and then I can use my question mark to also help me rearrange that question. But so I've got that being 34.6 grams of lead. And then this is my specific heat, and I've got all my units with it. And then my temperature, my final temperature is that 29.7, and my initial temperature is 104.6. And then I'm going to not put it in my calculator. I'm going to just keep filling in my terms here, just for that, consistency. So I've got that value. This again is my question mark, and then my delta T. Final minus initial. Notice my final is going to be the same as this top number for both. Again, I know I keep saying it, but I'm still saying it. And then I'm going to subtract out my initial value, 22.4. And if you wanted to label this, final and initial, that all works. So we can see that we are trying to solve for this. So this side is the right-hand side. And then I'm going to put lead. This is my left-hand side. Oops. And so if I want that to be all by itself, I need to divide both sides by mass and delta T. And I'll use this wonderful power, bring it down, and that gives me my C of my unknown. I like doing it that way. I feel like it's less writing in the long run because all of these are at least like 3 or 4 numbers instead of like one letter. And I think it also helps make sure it gets in there correctly. So we will go over here and we will say that this is negative 34.6 grams times 0.129 joules per gram degrees Celsius times, and look, I can put this in like this in my calculator. I don't even have to solve for it at that point. Oops, 104. Make sure you actually write it over correctly. 6 divided by, and it's my mass 30.4 grams and 29.7 minus 22.4. And just to kind of point out, so I took this and it went in that spot. I took this and it went in that spot. I took, well, it was the whole delta T term that I put in there as that subtraction. Here's this mass, put it in that spot. And this whole term I put here. I'm just going to put in my calculator. Negative 34.6 times 0.129 times parentheses. I'll scooch it over so I can see it all. 29.7 minus 104.6. Make sure you get that in there correctly and you don't do 104.6 minus 29.7 because you'll end up with a negative term. Divided by. Now, if you want it like this, and you want it to say multiplying on the bottom, you need a parentheses there. Times parentheses 29.7 minus 22.4. So you can do it like that. I'll close my parentheses. And you get this number. .521. And hang on a second because I'm gonna put something else in there. But 1.5, I'm gonna make sure I got all my numbers in correctly. Okay, so that's one way to put it in. I personally don't like all those parentheses in my denominator, so I'm gonna go back to here and delete out my denominator and show you how I usually do these. I do 30.4 and then I use the divided by key again, and then I would put it in with my parentheses. As you can see, oops, what did I do? Oh, I just realized on this top one, I didn't put in the 4. I did a 1. Okay, now you can see both of the numbers match, whether you use the divided by and the divided by or the parentheses. So it's 506. If you ever do this and you end up with a C that's negative, you dropped a negative sign somewhere. If you ever end up with a mass that's negative, you dropped a negative somewhere. And even T's, they can be negative, but it's not as common. So just be aware when you get negatives coming out of this one. Okay, and the other little bit is how do we figure out our sig figs? Right now, we've got 3 sig figs there, 3 sig figs there. Well, it's a constant, but that has 3 sig figs. And I know it looks like all these numbers should have 3 sig figs, but when there's a subtracting involved, you should check it. So I'm going to do that 29.7 minus 104.6 and write it over to the side. So this one is negative 74.9. Notice that with my line, that all lines up like that. So that has 3 sig figs. So this top term is going to have 3 sig figs. And then I'm going to do my bottom term, 29.7 minus 22.4. And that gives me 7.3, again, my line right there. So 7.3. Now notice this one is 2 sig figs. That's actually 2 right there. So that's why your answer is 1.5. And if you're worried about your units, I didn't write my units right here. That's degrees Celsius, and that one's degrees Celsius. So those two cancel. And then my grams cancel. And that looks like I'm left with these units right here, joules per gram degrees Celsius, which makes sense.